Hello everyone. So yesterday we did something about concave mirrors and they were image formation by concave mirrors in chapter number 10, that is light, reflection and refraction. Fine students, so here we were left with the two more topics, that was the image formation by convex mirror. The image formation by convex mirror. Now students, you all know about what is convex mirror. The outer curved surface area of a mirror is said to be a convex mirror. Fine. As I told you earlier, the usage of the convex mirror is used in rear view mirrors of the vehicles, that is cars and bikes, or the side glasses we are getting. They are generally made up of convex mirror so that we can have a better view of it. So today we are going to study two cases of image formation by the convex mirror. Let us start with the first one. The first one is that at infinity. Fine. So at infinity, that is the object distance. So the first image formation is at infinity. That means that if the object is kept at infinity, what we need to do? Okay. So let us continue with it. First of all, we will draw a convex mirror, that is the outer curved surface area. So we have drawn the outer curved surface area with it. Now what we need to do, as general what we are doing in the concave mirror, we are going to draw a pole. So over here, we are going to draw a pole P. That is the principal axis, that is this imaginary line passing through this, and the center will be said to be pole. Okay. Now what we will do is, suppose I am having a focus over here and a center of curvature over here. In convex mirror, as the image is always formed as a virtual and erect, that is, the image is always formed behind the mirror. The image is always formed behind the mirror. So what happens? You also need to draw a focus over here, as well as the center of curvature over here. Name these as F prime and C prime. You can also name these as F and C and these as F prime, C prime. It will work. But you need to make two focus and two center of curvatures for a convex mirror. Fine. Now what is the question given over here? That is, the object distance is kept at infinity. So if the object distance is kept at infinity, we can keep this over here. Say this is your object. Okay. So now what happens? Enormous numbers of rays are going from everywhere. Okay. Or let us take it from both the axes, and so we can write, say, object is kept over here. Okay, so now what happens? Enormous numbers of rays are coming over here and striking back. The same thing is happening over here. Okay, I have drawn only two rays. It will work because it will be clear for the understanding. As well as here, there will be infinite number of rays which are passing and striking over on the convex mirror. But for the clear understanding, I am drawing only two rays. Okay, these both rays are said to be the incident ray on the mirror. These both rays are said to be the incident ray on the mirror. Now, as these rays strike on the convex mirror, they reflect back. Okay, so now what happens? We can draw an imaginary line passing through this, and so on the same, it should not change its direction. So, okay, I am drawing an imaginary line passing through the incident ray. Again, I am also drawing an imaginary line passing through the same incident ray over here. So we can see that it is intersecting at the another focus, that is behind the mirror on the convex mirror. Okay, so here you can see that if the object was kept at the infinity, the image formed is at the focus. Okay, at focus. the image formation is at focus, and so it is said to be an image distance, and so it is said to be an image distance. So if the object distance was at infinity, then image distance will be at focus. But the change over here from the concave mirror is that the image is formed behind the mirror. The image is formed behind the mirror at the focus. So it will be highly diminished, small size and highly diminished, but what? Virtual and erect. So first of all we need to write the size, and size I am going to write over here. You can write highly diminished or point size. Fine. You can write anything you want. I am writing over here the highly diminished or point size. Highly diminished or point size. And as the image is from behind the mirror, you need to write that it is virtual and erect. It is virtual and erect. Fine. This is the nature of the image, this is the size of the image, this is the image distance, and this is the object distance. In examinations, if they are asking this, they will be only giving us the object distance or the image distance, one of the two, and we need to write everything as well as we need to draw it. That is compulsory. It can be asked for the 3 marks, so you please pay attention on these things. Okay, I hope you are clear with the first thing. Now let us go for the second thing, and second thing is between infinity and pole P. Okay, and that is our what we say as object distance. Fine, and that is our what? Object distance. Now the first thing was at infinity, now we need to write that between infinity and pole P. Here pole P is this. Okay, I hope you got it right. So that is between infinity and pole P. Again we need to draw the same thing, that is the convex mirror. So first of all I am drawing a convex mirror over here. Again we will be drawing a pole with some height. Okay. Over here that is P. The same thing we are going to repeat. I hope you know that the focus should be half the distance of center of curvature from the length. Also we can say that R is equals to 2F. R is equals to 2F, or F is equals to R upon 2. F is equals to R upon 2. So these are the things we need to draw. Now if the object is kept between infinity and pole P, I can keep something over here. Okay. So now what happens, students? The first ray will go and strike over here. Barabar. And now these rays goes directly to this, and one of the rays will strike over here and goes back. Okay, this is the imaginary line I have drawn. I hope it is clearly visible to you. This is the imaginary line I have drawn. I am drawing again. First. Okay, so this is the imaginary line I have drawn over here. Now what happens? These rays strike back. We can draw the imaginary line again over there, and so we can draw. There is a mistake over here. Let me rewrite it once again. So now what we can do is, this ray goes back over here, and so we can draw an imaginary line. So here you can see that there is this small distance over here. Okay, and that is the image formation where both the rays are intersecting. That is the image formation where both the rays are intersecting. So if you need to name these as A and B, then we can say these as A prime, B prime. Okay, so if you can say this as A and B, we can say this as A prime, B prime. So students, over here you can see that if the object distance was between infinity and pole P, object distance was between infinity and pole P, the image distance will be between pole and focus. Okay. So image distance will be between pole P and focus F, and that is said to be an image distance. And that is said to be an image distance. I hope you are clear with this. Fine, this is quite small, but you need to know that image is always formed behind the mirror, so of course it will be virtual and erect. Virtual and erect. Okay, and the size is quite small, but not a point size, as it was here a point size. This is not a point size, so we will write size is small and diminished. Small and diminished. Okay, small and diminished. So between infinity and P, that is object distance. Between pole P and focus F, that is image distance. Small and diminished. Virtual and erect is the size of nature of the image given. I hope you are clear with this. So this was the convex mirror, or say the image formation by convex mirror, that you need to know. In concave mirror we are having 6 cases, whereas in convex mirror we will be having only 2 cases. So these both are quite important, as only 2 are given of them. You need to go thoroughly through it. Okay, I hope you are clear with these things. Fine. So the next thing what we are going to study is sign conventions. Now what is the meaning of the word convention, or say the sign conventions? Here sign stands for, in any mirror, if you are using any object distance, image distance, the length of the focus, the length of the curvature, the radius of curvature. Fine. Then how we will keep the positive sign as well as the negative sign, that is known as sign conventions. In short, if you will tell, sign convention stands for rules for making an image distance as well as the object distance on any curved surface area. Fine students, I hope you are clear with this. Sign convention stands for rules and regulations of image formation on any curved surface mirror. Fine, then what are the rules and regulations that we are going to study? Okay, so our next topic is what? Sign convention for mirrors. Now as we saw, 2 different types of curved surface, and one was the concave surface and another was the convex surface. So let us say we will draw a common one, that is a concave surface mirror, and we are taking this the origin. Say this was a pole, this was a focus, this was the center of curvature. Okay, I hope you are clear with this, students. Now the rules and regulations states that object should always be kept on the left hand side of the mirror. Okay, so on my left hand side will be this, so object is always kept on the left hand side of the mirror. That is the first rule. Each and every time whenever you are making an experiment on this, or you are keeping any object, you should always keep the object, that is the real one, the object should be always on the left hand side of the mirror. It should be on the left hand side of the mirror. What is the first rule? So the first rule is object should be always kept on the left side of the mirror. Okay, so this is the first rule. object should be always kept on the left side of the mirror. Either it is a convex mirror or it is a concave mirror. You need to compulsory keep the objects on the left hand side. Fine. Next thing, if it is an object distance, image distance, focus, radius of curvature, center of curvature, anything, you need to always measure it from the pole and not from here. Find the distance of the object distance, image distance, radius of curvature as well as focus. Everything is being measured from pole of the principal axis. Okay, pole is said to be the origin point. Pole is said to be the origin point. Fine. I hope you are clear with this. So what I was telling is object distance, image distance, focus, center of curvature, everything should be measured from the pole P. Okay, the object distance, image distance, focal, center of curvature should be measured from pole P. Should be measured from pole P. So this was the second rule. If I am keeping an object over here, then I need to measure the distance between P and this. I need to measure between P and this. Okay, I hope you are clear with this thing. Fine. Now we are moving on to the signs that either we need to take things positive or negative, and that is quite important over here. To make this thing comfortable and easy, let us make a 4 quadrants. Students, you know this. This is your x-axis and this is your y-axis. Fine. On the right hand side of the mirror, we always need to take things positive. Okay, on the left hand side of the second quadrant, this is always your first quadrant. Okay, so in first quadrant everything is positive. On the first quadrant everything is positive. On the second quadrant the x-axis is negative but y-axis is again positive. Okay, and this we will be saying as second quadrant. This will be our second quadrant. Over here, we will be taking 2 more things, and that is negative, because over there in the third quadrant, x-axis as well as the y-axis both are negative, and this is our third quadrant. And the fourth quadrant will be again x-axis will be positive, but y-axis will be negative, and this is our fourth quadrant. Okay, so over here, think that this pole is the origin. Okay, so this is your second and third quadrant. This is your first and fourth quadrant. Name this as first, second, third, and fourth. So if we were telling that object should be always kept on the left hand side of the mirror, the left hand side of the mirror is what? Second quadrant, then it should be always taken as positive. Fine. So what we will write? Object distance kept on left side of x-axis should be negative. Should be negative. The object distance kept on the left hand side of the x-axis should be negative. Should be negative. I hope you are clear with this. Anything on the left hand side and that is the object distance, it will be always negative. And object distance kept on the right hand side beyond x-axis. This is your x-axis. Beyond that, that will be positive. Okay. The fourth point will be object distance on right beyond x-axis should be positive. Fine. The very same thing we are going to repeat in the y-axis also. So y-axis stands for what? In y-axis it is perpendicular. The height measured above the x-axis will be, the height measured above the x-axis is taken as positive. Okay. Is positive, and the sixth point will be height measured below x-axis is negative. Okay, I hope you are clear with this. It is as simple as this quadrants. Everything on the left hand side of the x-axis negative, on the right hand side will be positive. Okay, height measured upwards will be positive and height measured downwards will be negative. Okay, one more thing we need to do is, no, this is still here, it is okay. I hope you are clear with these things. Okay, so the height measured above x-axis is positive, below x-axis will be negative. Object distance, image distance or focal curvature and anything can be measured from the pole, and the object should be always kept on the left hand side of the mirror. So these are the general rules and regulations of the sign convention, students. I hope you are clear with this. Okay, let us move on to the next point. Over here I am rubbing this, and that is mirror formula. What we are going to study is mirror formula. Okay. So what about mirror formula we will talk. Now what is mirror formula still? Now what is mirror formula? What we studied was, say that there is a concave mirror or a convex mirror. I am drawing a concave mirror because in textbook it is given. You can also write or draw a convex mirror. It is one and the same. Suppose this is your pole, focus, center of curvature, and the object is kept over here. So the distance between the object distance and pole is denoted as u. Okay, so we will write what? That object distance OD is represented as U. If we are having any another image, then we will name this as image distance ID as V. Okay, and focal length F as F. Okay, so the general formula for the mirror is 1 upon V plus 1 upon U will be always equals to 1 upon F. This is the main formula what we will be using in the whole lesson for the solving numericals. Okay, so this is the general formula. 1 upon V plus 1 upon U is equals to 1 upon F. Students, sign varies according to the usage of convex mirror or a concave mirror. There will be always a change between the concave mirror and convex mirror, but the formula will remain same. That is 1 upon V plus 1 upon U is equals to 1 upon F, where V is the image distance, U is the object distance, and F is the focal length. Now we also know one more formula, that R is always equals to 2F. So we can also write F is equals to R upon 2. Now if we can write F is equals to R upon 2, instead of this F we can substitute the values of R upon 2. and so that becomes 1 upon V plus 1 upon U is equals to 1 upon R upon 2. Okay, instead of F what I wrote is R upon 2. Now this 2 is denominator, that moves on to numerator. Answer can be also written in the form of this. So this is our second formula for image mirror formula, and this is our first. So 1 upon V plus 1 upon U is equals to 1 upon F, and 1 upon V plus 1 upon U is equals to 2 upon R is equals to 2 upon R. Fine, I hope you are clear with this. This was the mirror formula. And on this we will be solving many examples. Fine, but first of all you need to understand this. If the object is formed, it is said to be U. Image is formed, that is V. We need to find focal length, and we can solve by this formula. If focal length and object distance is given, we can also find the image distance through this. If image distance and focal length is given, we can also find the object distance through this. So these are one of the common formulas for mirror formula. Okay. Next topic what we are going to study is magnification. Have you heard the word magnified or a magnification? Of course, yes. Where magnifying glass. Okay. Magnifying glass, also known as magnification. What is magnification? Anything that looks bigger in size is known as magnification. That was the general idea what we were telling till now, or what we were knowing till now. The main magnification is the change in height of the image with respect to that of object. I hope you are clear with it. The change in height of the image with respect to object is known as magnification. It can be also larger than the object. Image can be also less than the object. Still it is known as magnification. Fine. So what is the definition of magnification? The change in height of the image with respect to object is known as magnification. The general formula for magnification is M is equals to H prime upon H. Here H prime is the image height. H prime is the new height we got, and so it is known as image height. And H is what we tell as object height. I hope you are clear with this. M is equals to H prime upon H. M is equals to H prime upon H. One more formula we are having about M is minus V upon U. You know, students, what is V? That is image distance. You know what is U? That is object distance. Okay, so there are two formulas for magnification. That one is H prime upon H, another is minus V upon U. So M is equals to minus V upon U and M is equals to H prime upon H. We are having two formulas, and we can also compare these things like M is equals to H prime upon H is equals to minus V upon U. So this was the general form of magnification. This was the general form of magnification. The change in height of an image with respect to that of object is known as magnification. M is equals to H prime upon H, that is image height upon object height. Fine, I hope you are clear with this mirror formula. What we did about this, the sign conventions, find the sign conventions and the mirror formation by convex mirror. So this was the general things we studied today. You need to go through it, as today's lecture was quite important for the examinations too. Thank you.